And we're live. Good morning, everybody. So it is Thursday. Gosh, we have like a week and about a couple of days left. We're going to make it, okay? So test next Friday, and then we're done, unless you're behind. So if you're behind, first of all, get caught up in Chapter 8. If you haven't done it, ask me for it. If you have it, get it to me. We'll put those in the grade book real soon, and then I'll start calling parents for those kids who don't have it, okay? So get caught up, all right? We got to get caught up so that everybody can get a good grade in the class, okay? So, homework. First of all, let's look at last night's homework. We're going to go to 9-2. These are the answers I have. Number 1, I have 10 squared to 2. Number 1, if you square that, squared plus that squared, it does equal 1. Number 3 is 8. Number 4, because the 12 is here, you go 12 divided by the square root of 2, which is 6 squared to 2. 5, x is 15 squared to 3, y is 30. 6, y is 11, therefore x is 11 squared to 3. 7 and 9 is sitting here, so you go 9 divided by the square root of 3, which is 3 squared to 3. And then you double that, and you get 6 squared to 3. On number 8, to get the perimeter, here's diagonal 32, so therefore this is 16 squared to 2 because it's a square. And then if you add up the 16 squared to 2, you get 64 squared to 2. 9 isosceles triangle, if this is square root of 3, it does make a 30, 60, 90 triangle, so then this becomes 3, this becomes 3, double that from there, and you get 2 squared to 3. So the perimeter, the area is that times that. Find the base. So the base is 6, okay? And then finally 10, 7 squared to 3, that makes that 7, so then this becomes 14. That's 14 squared to 3, that times that. Divided by 2 is 98 squared to 3, or 169.7. Okay, anyway, that was last night's homework. Today, let's take a look at today, okay? Today's work deals with this, okay? If you get a right triangle, okay, and you draw its altitude to the opposite side at 90 degrees, it really creates 3 triangles. 1 is the big triangle, 2 is the medium triangle, and 3 is the little triangle, okay? So it turns out that there's a ratio between this altitude and the 2 pieces of the side, okay? Turns out that this side, this x, over one side, we'll say a. They've got it written the other way, but we'll just do it this way. Oh, let's do it that way. A over x, this side over this side is going to equal this x over b, okay? So if that happens, this is called a geometric mean, okay? So if you multiply x times x, you get x squared. You multiply a times b, and you get ab. Square both sides, and x is equal to the square root of a times b. So a geometric mean is simply between two things. It's just the multiply that times that, and the square root would be a geometric mean, okay? And you'll see that in today's homework, okay? It's pretty easy. Now let's go back to this, okay? This is kind of a strange thing because we do wind up with 3 different triangles, okay? So let's take a look at an example of that. So here's my example, okay? I've got a big right triangle, okay? And inside of it, I have 2 other triangles. And I think you can probably see the 2 others. So I've got a medium triangle here. Let me do that in a different color. It helps to see them in color. If we'd do this in class, if we were here in class, we'd actually draw it together. And then there is another triangle. Let's go ahead and color that in red. And then we've got the bigger triangle. So let's go ahead and take a look at all 3 triangles. So first of all, let's take a look at this big triangle. Okay, the big triangle I'm going to redraw again, okay? And I'll draw that one in green, okay? So the big triangle, I'm drawing green. I am not an artist, no doubt about that. And so if I redraw this big triangle with A, C, and B, okay? Then in the same orientation, I'm going to take the purple triangle. Same orientation, which means I have to pick it up and flip it over so it's in the same orientation. So here's my medium triangle. And that's my purple triangle. I'm going to redraw it. Okay, purple, color it in. So I had to turn it around. So when I turn it around, D is now here. Do you see that? D flips to here. B is still here. But then C, this point, see this angle here, is C right there. Okay, now finally there's the little triangle. The little triangle, but I have to redraw that in the same orientation. So I'm going to put the little triangle right here. And I'm going to make that red so you guys can see it. And I wanted to draw them all in the same orientation so you can see that they are similar, okay? So I've got a 90 degrees here, and that's my D. See, D is here, and then A turns out to be there, and C is there. Well, they are similar. If they're similar, then we can set up these ratios. We can say, for instance, this side goes to this side as this side goes to this side. Okay, so let's just write that one down. I can say AC goes to AD as AB goes to AC. Or maybe we could say something like this. We could say maybe CB goes to DB. As maybe we could say AB goes to AC. And of course, CB, my bad. So then you can see there's lots of ways to set this up. This side goes to this side, as this side goes to this side, this side. As long as you're consistent, you can set up all these ratios. So there's a whole lot of proportions to set up. Well, we could take apart the triangles and draw them, but there is something that makes it a little bit easier. If we have the exact same picture, and if we happen to know the altitude, okay? So this is called the altitude theorem. So this is the altitude. Let's just call it A. The altitude of a triangle is the height of it. And this is my base. The altitude breaks the base into two parts. Let's call this B1, B2. Well, it turns out that there's a geometric mean. A goes to B1 as B2 goes to A. So if we set up the geometric mean, or better yet, let's just make it easy. Let's say the altitude squared is equal to this part of the base, not the whole thing, but this part of the base times this part of the base. Okay, if you have that information, it's a little bit easier than taking the triangles apart and finding out what's similar. Sometimes we have to do that, okay? Now, the leg theorem is another one of these ways to make this a little bit easier, okay? So we take a look at the leg theorem. So this is the leg of my right triangle. This is my base. And this is the part that's attached to my leg right here. Let's call this B2, okay? And this is B1, right? Just like up above, okay? So the leg theorem says the leg squared, this leg squared, is equal to the piece that's attached times the entire base, okay? Or somebody could say, well, Mr. Davies, isn't there a leg over here? Yeah, there's a leg over here. There's two different legs on the right triangle, right? There's my two legs, leg. So you can set up the exact same ratio. You can say leg squared, but this leg squared is equal to the piece that's attached, the base part that's attached, that's B1 times the entire base. Okay? Now, let's see if that can help us. So let's take a look at some of the examples that I have today. So first of all, I want to do a few of these, okay? So let's take a look first. I'm going to flip my page and let's do number 9 first, okay? And then I want to do number 11, okay? Let's do 9 and then do 11, okay? So number 9. Well, I could take the triangles apart. There are 3 triangles, and I could do it this way. But what I notice is that's a leg, and that's a piece of the leg. Oh, doggone it, I may have to do this different. Oh, I can just use Pythagoras theorem. Sorry. Why didn't I see that? Duh, let's just use Pythagoras theorem, okay? 32 squared plus 24 squared equals x squared, because I'm using, I was about ready to do this a hard way. Why do it a hard way when all I have to do is find an x, right? Let's just do that, right? Sorry about that. Why make it hard when I don't have to? I almost tried to make it hard. 32 squared plus 24 squared, okay, and I get 1600. And I'm going to take the square root of 1600. 1600 equals x squared, square root, that's probably 40. I'm pretty sure that is 40. And I get 40, okay? That was pretty easy. Okay. All right, now let's do 10. 10's different because you've got the leg, you got the pieces attached, you got the entire thing, okay? So I'm going to use this theorem, okay? I've got the leg, I've got the pieces attached, I've got the entire base, so let's set that up. So I'm going to say 6 is the leg. 6 squared is equal to this piece of the base that's attached times the entire leg, which is 12. Now if this really confuses you, then take the triangles apart and you can see how the ratio is set up. But I'm going to do it this way because I think this is easier. 36 equals 12x divided by 12. X is going to be 3. Okay? And now look at 11. 11, I've got the altitude and I've got the two pieces. All right, if I take a look at the altitude and the two pieces, I can use the altitude theorem. So I can say, okay, the altitude squared is equal to 18, which is base, part of the base, times the other part of the base. And if I were to multiply, it's 18 times 8, I get an answer of 144. And if I square both sides, all right, I get x equals 12. Okay, there you go. That was pretty easy. Now, I'm going to go back to the first page because the first page is a little bit different. Okay, number 3. I'm going to do number 3, and then we'll do number 6, and we'll be done, okay? Now, the problem with number 3 is that I've got the altitude, but I don't have this piece or this piece. I can't do Pythagoras theorem because I don't know anything about this side. I can't do Pythagoras theorem because I don't know anything about this side. So on number 3, I can't use this theorem because I don't know these two pieces. I can't use this theorem because I don't know this piece or this piece. So I'm going to have to do it by taking the triangles apart. So what I see is, first of all, I'll do it in a different color. I see a medium triangle. So I'm going to take my medium triangle and set it up. Okay, so my medium triangle in red, I've got 8, I've got x, and I don't know what this is. Okay, but I don't know if I need to. Let's look at the big triangle, the entire big triangle, okay? Okay, so if I look at the entire big triangle, purple, I like colors, makes it easier to see, to visualize it. There we go, I'm not much of an artist, you guys see that obviously. So if I use the big triangle, here's my 6 goes here, my 8 goes here, my 10 goes here. Do you see how that orientation, if I turn it around, flip it around, so it's the same orientation? Well, now I've got a proportion, I can solve this. So sometimes you have to do this, okay? So I can go x goes to 6 as 8 goes to 10, right? And that makes it easy because I can solve it. So I can go x corresponds to 6 as 8 corresponds to 10. Okay, so I set my proportions, cross multiply. Okay, multiply straight up to 6, that's easy. And I go x is equal to 6 times 8 divided by 10. X is equal to 48 divided by 10, or 4.8. Okay, boom. So sometimes, and on number 4, you'd have to do the same thing. There's no other way to do it except for to take it apart and do the two different triangles, okay? Same thing on 5, I'd have to take it apart and go ahead and do the same thing, okay? Now 6, geometric mean, that's easy, okay? Geometric mean, we're going to say x is equal to the square root of 3 times 12, x equals square root of 36, x is 6, okay? That's all you got to do for the geometric mean, is just this times this, square root of that times that, okay? Same thing here. Geometric mean is just the square root of this times that. That's pretty easy. Okay, so that's what I have for homework. Okay, so if you cannot use either one of these handy little formulas, then unfortunately you may have to take the triangles apart and set up the proportions. Okay, so what's our homework for today? Page 294. 1 to 7 all. So please get it done at this point in time. Most kids are getting great grades. If you're behind, you probably won't get a great grade. If you're way behind, you're going to get an incomplete, and that's going to suck. So get her done.